Problem 2 Part A asks if you invest P sub $0 at 7% annual interest and the future value is computed by continuous compounding, how long will it take for your money to double? So to solve this problem, all we have to do is use the continuous compounding formula and sub in a value of 2 for the final value and a value of 1 for P sub 0. And what we get is the natural log of 2 is equal to 0.07t, where t equals 9.9 years for your money to double. Part B asks, suppose you invest P dollars at R% annual interest and the future value is computed by continuous compounding. If you want the value of the account to double in 2 years, what is the required interest rate? To solve this problem, we do the same thing, except for instead of making our exponent of e 0.07t, which is r times t, we put in t and we solve for r. And what you get after solving for r is 34.66%, which is the rate to double in years, or in the rate that is required to double your money in 2 years. So then part C asks, or talks about a rule of thumb used by people to determine the length of time to double an investment as the rule of 70, and the rule is that it takes about 70 over r years to double the investment, where r is the rate at which what your interest rate is. And then it asks us to graphically compare this rule to the one isolated in part B. So all you have to do is t is equal to 70r. I plugged in r over here of 34.664 based off of what we got from our interest rate in part B. And then I got t is equal to 2, so it should be 2 years to double our rate. But to find it graphically, we just graph it like this. So it should look something like this. Essentially what this graph is saying is that the higher your interest rate is, the lower your interest rate is, the longer time it's going to take you to double. And then the more you increase it, the less time it takes to double. And you can see at 35% rate, it takes 2 years.